Okay, so for this problem, we want to find the roots of the equation. And I'm going to zero in on those roots. What does it mean, roots? Roots have like several different words that go with it. For me, what I care about right now, that's the answer to my quadratic. So first, I'm going to factor it to make it a lot easier to figure out that answer. I notice I do not have a number in front of x squared. Awesome. Doesn't really look like a special pattern there. So I'm going to use my first method of factoring. I'm going to go ahead and put a set of parentheses. I'm going to notice it's equal to 0. I'm going to keep that. Okay, that's key. That'll help me figure out the answer later. So I'm going to ask myself, what two numbers will multiply to give me negative 36, but add to be negative 5 there? And I also notice this is a standardized test question, which means it is multiple choice. Yay, we like that, because we know right away these are all dealing with 4s and 9s. So am I going to spend time wasted and try and figure it out? No. I'm going to focus on 4 and 9. I know that's what it's going to be. So those 4 and 9, they have to multiply to be negative 36 and add to be negative 5. The only way that can happen is if you have negative 9 and positive 4. That has to be your factors. That does not mean that's your answer, so be careful. Okay, so negative 9 and 4 will multiply to be negative 36, but they will add to be negative 5. So I'm going to take those factors and put it into my problem. First spot is always reserved for x. Okay, so now I have my factored form. Now I have to figure out those roots, or the answer. To do that, I'm going to invoke my friend, the zero product property. That says that if I have two sets of two binomials equal to 0, to figure out what each of those x's are, I can take each one and set it equal to 0. My zero product rule says if you're multiplying two things to get 0, one of them has to be 0. So to figure out what that is, you're going to set each one equal to 0. So we're just going to use algebra here. Add 9, you get x is 9, subtract 4. You get x equals negative 4. So our answer to this one is C. Now, this is a tricky question because you're going to think, when I figure out those numbers to go into my factors there, you're going to think that's your answer. No, don't do that. Factor it carefully, then set each piece equal to 0 to figure out the answer. And later we'll talk about how these roots here, when you graph this quadratic, that's where your graph crosses the x-axis. We'll talk about that later. Okay, so now we're going to talk about how on earth we factor when you have a leading coefficient that's not 1. So you'll notice our leading coefficient is a 5. Okay? Now, the way I learned to do this is doing a lot of guessing and checking. We don't want to do that because it takes too long. We're going to use this method that I actually saw at Sylvan when I worked there. But we're going to make a chart, and I always call it the BAC chart. Okay? So what that means is, if you'll remember way back, our quadratic is in the form of ax squared plus bx plus c. That means whatever number is in front of x squared, your coefficient of x squared is a, coefficient of x is b, and then your constant is c. Okay, so to figure out this chart, I'm going to look at my quadratic, and I'm going to say my coefficient in front of x, my b value, is a negative 17. I got to watch that negative. And then a and c, my a value is in front of x squared, and my c is at the end. So a times c is 5 times 6, which is 30. The reason I set up this chart is because I'm going to change this quadratic into a different type of factoring problem. Okay, so I have my chart ready to go. Now here's where I think of those factors. I'm going to say what two numbers will multiply to be 30 and add to be negative 17. So it's the same thought process. Okay, so we're going to say 30. Well, we want it to equal 17, so I'm not going to worry about 6 and 5 because that won't work. Let's think of, 15 and 2. 15 and 2 will multiply together to give you 30, and it's really easy to add those guys to get 17. Now we got to worry about the negative. We want to multiply them to get positive 30, add them to get negative 17. The only way that works is if they're both negative. Okay, so I have my factors from my BAC chart. Now I'm going to use those two factors and I'm going to rewrite my middle term with them. So instead of negative 17x, I'm going to use these two. I'm going to say 5x squared minus 15x. I have to keep that x there because I'm replacing 17x. Minus 2, again, x, plus 6. So I use the two factors from my BAC chart to turn my quadratic into an actual factoring by grouping problem. Okay? So I'm changing my 3 terms to 4. I'm stretching it out a little bit. Be careful to use those factors but put an x next to it. Very easy to forget that. Okay, so now I have 4 terms. So I'm going to use a technique called factoring by grouping. I'm going to put a set of parentheses around my first 2 terms and put another set of parentheses around my last 2 terms. Notice how I was careful to keep that negative with that term. Now that I've done that, now that I've grouped them, I'm going to pull out what's in common with each term there. So I look at 5x squared minus 15x. First thing I notice is that they both have an x. So I'm going to factor that out using the distributive property. Put that x on the outside. That's what happens when you factor it out. You actually are dividing it out. Okay? Then I notice that they both could be divided by 5. So that's something else that they both have in common. So again, I factor that out. I'm going to divide it out. So if I take 5x squared and I divide it by 5x, all that's left is x. What I'm doing is I'm going 5x squared divided by 5x. My 5's cancel out and give me 1. And remember your exponent rules here. You're going x squared divided by x. Subtract those exponents and you're just left with 1x. Okay, and then the same deal here. I'm taking this x away. Remember your distributive property. When you have something in front of parentheses and you distribute it throughout, now we're doing the reverse. We're taking it out. We're keeping that same sign. 15x divided by 5x is 3. I'm going to use the same thing here. My objective is I want these parentheses of whatever's left to match. Okay, so negative 2x plus 6. I got to be careful of that sign. I want that sign to match. So I got to factor that into the equation too. So what's in common here? I don't see an x in common, but I do see that those both could be divided by 2. I'm going to do that, but I'm actually going to pull out a negative 2 to make this sign in the middle change. So negative 2x divided by negative 2 leaves me with an x that's left. So negative 2x divided by 2. That's what I did right there. Excuse me, negative 2. That's what I took out. And all that was left was x. Then I do it again. I go 6 divided by negative 2. When I do that, all that's left is that negative 3. Look at that. They match. So then I'm going to take whatever's in the front, put it in one set of parentheses, and whatever's in the parentheses, just one of the ones that match. And that's my factored form. It's a lot of steps, but once you get more comfortable with it, it actually does go a lot quicker. Okay, so the steps are, make a BAC chart, pick those factors, use those factors to rewrite that middle term and then group it. And we will do a lot of this. This is out of your textbook in chapter 4. So if this is confusing, best strategy is to watch the next problem, but also watch this part again. This is on my website.